Have you ever thought about your plans for the future? Like after college, applying for jobs, retiring from work, or even death?
Wait, death?
Yes, death. But before that, we all wanted to make sure that our loved ones were secured and covered financially, even after we retire from our jobs.
But how?
Here's how it is. There are life insurance policies that may help meet our family's needs.
Like what?
These life insurances are called annuity and perpetuity.
So, what are these?
An annuity is an insurance contract that an insurance firm or financial institution distributes with the goal of paying out invested money in a set income stream in the future. For instance, you might decide to start making investments exactly 1 year from now and then hold up for 10 more years. If you make a deposit of, let's say, 1,000 pesos at the end of the first year, then at the end of the second year, and so on, then each amount will be returned to you at the end of the cycle with interest. And if you keep making deposits, then at the end of each year, the total amount will be returned to you with interest. On the other hand, perpetuity is a special case of annuity. In perpetuity, the stream of equal cash payments is expected to continue forever. But did you know that we can calculate these life insurance policies by using the concepts of infinite geometric series?
Really? But how?
This figure shows the timeline for a typical perpetuity. To get the present value of perpetuity, we will use the equation given by Dikov on terminal values. Following the point at which we can predict future cash flows, the terminal value displays the current present value of all such cash flows. But to suit the values given in the figure, we will replace the variables in the formula with those that are in the figure, where PV is equals to the summation of t is equals to 1 to infinity c sub t over 1 plus r raised to t, where PV is the present value of perpetuity, c is the amount of cash flow received every period, and r is the required rate of return. By using the equation, we get PV is equals to c over 1 plus r plus c over 1 plus r raised to 2 plus c over 1 plus r raised to 3 and so on and so forth. Again, we factor 1 over 1 plus r out starting from the second term on the right-hand side of the equation 1, where PV is equals to c over 1 plus r plus 1 over 1 plus r multiplied to c over 1 plus r plus c over 1 plus r raised to 2 plus c over 1 plus r raised to 3 plus so on and so forth. Notice that the term in the brackets is the same as the present value of the perpetuity in equation 1. Replacing it with PV, and equation 2 becomes like this, where PV is equals to c over 1 plus r plus 1 over 1 plus r times PV. Then, multiply both sides by 1 plus r, where 1 plus r times PV is equals to c plus PV. Then, expand the left-hand side, where PV plus r times PV is equals to c plus PV. Then, subtract PV from both sides, where r times PV is equals to c. And lastly, dividing both sides by r gives us the present value formula for perpetuity, which is PV is equals to c over r.
We should know by now that the idea of an infinite geometric series can be used in the process of calculating insurance, particularly for companies in the finance industry. Although it may appear to be impossible to calculate the value, but with the help of this concept, we are now able to determine how much value it holds.